Hello everyone, my name is Emily Rita, and today I'm going to do a biology experiment concerning fermentation within the drink known as ginger ale. Now what is fermentation, you may ask? Well, allow me to tell you, fermentation is a process in which yeast consumes sugar, which allows it to produce mostly carbon dioxide, along with only some alcohol, but this experiment is going to focus on the carbon dioxide part of ginger ale. So this experiment aims to show us how that is. So we got all my ingredients right here, ready to make my homemade ginger ale in order to figure out the biology behind its fermentation. So we are going to make the ginger ale in this jar. And I'm going to be using active dry yeast, half a cup of regular sugar, shredded ginger, along with lemon and lime juice, all in this one container. So, to start, we are going to pour the sugar in first, since it's helpful to the fermentation process. And next, we are going to mix it in with the yeast.
And set them aside.
And then we will set them aside. All right, so I'm going to pour in the yeast for now, just so it can mix in. And now I'm going to shake it up so that it mixes, so fermentation can happen.
Not yet.
All right.
And then we need to add the lime juice to the ginger.
All right, and now I'm going to add the lime juice to the shredded ginger. And now I'm going to mix it. All right, you see how it's mixing?
Good job.
And this is doing good. All right, and now I'm going to add the mixture into the jar. All right, so I'm going to go take this little jar along the side of this. And that will be it. And now I'm going to fill it up with water. Cold, fresh water. All right, and that's exactly what I'm going to do. So it's filling up. It has to stay at room temperature so that it can work. Yeah, for 24 to 48 hours.
Stop.
All right.
Maybe one more.
All right. And now I'm going to fill it up. All right. So now there it is.
Do you want to mix it or just?
All right. So now we're going to mix this drink so that it can work. All right. Using this here spoon. All right. You see how it's mixing?
Do you want to say that you're using plastic and not glass?
Now, I bet you're wondering why I'm using this plastic jar instead of a regular glass. Well, the reason is because with glass, it's risky because if the experiment goes overboard, things might get really messy. So, to be on the safe side, I am using a plastic jar for this drink, which once it's done, maybe it could be served as a beverage that is drinkable.
I'll drink it.
Yeah. Yep. And
So you can put it back there.
and now I'm done with the mixture, so I'm gonna go put it back right here. And now I'm gonna close it and keep it at room temperature from 24 to 48 hours so that it can work, allowing the yeast to start the process of fermentation.
And say I'll see you again.
And I will see you again in the next 24 to 48 hours to tell you the results of this experiment. Thank you for watching. Greetings, everyone. Welcome back. Where we last left off 48 hours ago, I was making this drink called ginger ale. Now, the purpose of that was to find out its biology, and I have it all set up for you. The biology of ginger ale is that the glucose within it, which is also another word for the sugar, has been converted by the yeast into energy without the use of oxygen. And the energy that was produced by it is actually 4 ATPs instead of the original 36 ATPs, the latter of which is usually produced in well-oxygenated environments, which isn't the case for the 4 ATPs.
Also CO2 is produced.
And also CO2 is produced too.
Let's open the
And
bottle.
now we are going to strain it.
You can open it.
And now we can open it, but we must be careful. The jar has been made hard to dent as a result of being there for 48 hours. So we are gonna open it. And what do you know? It's ready to be strained.
Yes, bubbling.
And it's bubbling too, which further shows like just how well the experiment has gone. And now we are going to strain it, of course. All right, there it is.
Do you hear the bubble?
Yeah,
See, you can see the bubble.
and here's an example of the bubbles that have been present here.
Oh, it's gone a little bit, but it was bubbling.
And it's been fizzing up too, as you can see right here.
Yeah, it's fizz right here along the edges.
Yeah. And now,
That's it.
and I think that is it for this experiment. It turns out that it was correct all along. So thank you all for watching and have a good day.